Good evening, all. Can you hear me? Please do respond. Can you hear me? Is my voice is audible? Okay, fine. Yeah. Thank you, Maleshwari. Lavanya Krishna. Thank you. Rani. Thank you. Yeah. Damini. Thank you. Sushmita. Thank you. Naveen. Thank you. Yes. Thank you. Lakshmi. Thank you. Inexhaustible. Thank you. Fine. So I think today is a very low strength. Might be because of uh, holiday. Okay, fine. So today we will be focusing on a few bit manipulation related content, and we try to solve some problems using C++ code. So let me share my screen. Is my screen is sharing to you? If yes, please comment sharing. Is my screen is sharing to you? Yeah. Thank you, Naveen, Lakshmi, Sushma. Thank you all. Yeah, fine. Thank you. So today we will be focusing on yeah. Let me take few. Oh, yeah. So this was the content that we discussed in the last class. Yeah. Just we were going through basic operators and the control statement concept and its related problem statements. So today we will be focusing on a very important operators concept, that is bitwise operators concept. So what is a bitwise operators? How does the bitwise operators work? So let me try to explain with an example. Let us see, let us consider I have I have let's say I've given two numbers. Let's say A is a value 10 and B is a value 5. So now if I want to do a bit manipulation or bitwise operator wants to be applied between A and B. Let's say we have a bitwise and this symbol, bitwise or, bitwise exclusive or, bitwise complement, bitwise left shift, and bitwise right shift. Now just think about what happens if I do A bitwise and B. A bitwise and B. So what it is going to do is the value of A is represented in the binary format. So the binary form of a 10 is 1010. Excuse me, please. Slow. Sorry. Yeah. So the value of A is a 10 in the decimal format, and that will be written as a 1010 in the binary format. And the B, decimal value 5, is written as 0101. So 101 is 5. Okay. So now on this, it will apply AND operation. So the AND operation is, if both the bits are ones, the result is 1. If any one of the bit is 0, the result is 0. Right? So here 0 and 1 will become 0. 1 and 0 will become 0. 1 and 0 will become 0. 1 and 0 will become 0. So the entire value is going to become 0 in the binary format. Clear? And if I want to apply bitwise OR operation, let's say if I want to apply bitwise OR operation, that means I'm trying to perform A or B. Then it will perform something like, so the OR operation is going to result, if both are ones, then only, sorry, both are zeros, then only the result is 0. If at least one bit is 1, the result is 1. So 0 or 1 is going to be 1. 1 or 0 is going to be 1. 0 or 1 is 1. 1 or 0 is 1. So total this is going to give a value 15. Got it? So let's check first this AND operation and OR operations. Let's check it practically. Let me create a new file for today. This is a day 2. Sorry. Sorry. Command tool. Yeah. Day 2 technical. I created a new folder for today. Just let me close my current program. Yeah, day 2 technical. Yes. Now let me just remove all these unnecessary content. Yeah. Let me write using a namespace std. Fine. Now here, let us take the same int a equals to 10 and b equals to 15. Oh, sorry, 5 we have taken. Now let me write some integer result equals to a and b. A bitwise and b. And then you perform cout bitwise and is equals to, right? And let me print the result. Okay, and let me write cout. Just this is for getting a new empty lines before after printing the result. Now you can see when I give a and b as 10 and 5, what does my output operation, like a AND operation, will do? Now a is 10, which is written as 1010, and then b is value 5, which is written as 101, in the binary format, and the AND operation on this will result with 0 and 1 is 0, 1 and 0 is 0, 0 and 1 is also 0, 1 and 0 is also 0. So my entire result is going to be 0. So my result value, this value is assigned as 0. So here I will get 0 as a result, right? So let me check that. Save. Let me shift this to day 2 technical. Save and let me run and see the result. Yes. Now the answer is 0, right? Now let me write same result equals to A or B, A exclusive or B, right? And let me write C out bitwise or equals to, and then just display my result. Now for the same, what does the R will result? What do we get when I apply? So A is a 10, which is written as 1010, and B is 5, which is written as 0101, and on this I'm applying OR operation. On this I'm applying OR operation. So OR operation, 0 or 1, 1, 1 or 0, 1, 0 or 1, 1, 0 or 1 or 0, 1. So all are ones and the result is 15. Result is 15. Let's check. So run this and see the result. Bitwise OR operation is giving a result as 15. Right? Now let's apply bitwise exclusive OR. Bitwise exclusive OR. So exclusive OR symbol is a cap symbol. XOR. Bitwise XOR result. Right? Now just think about the result here. What does the exclusive OR will do? So my A value is 10, which is written as 1010, and B value is 5, which is written as 0101. Now what does my exclusive OR will do is, so if both the bits are same, the result is 0. If both the bits are different, then the result is 1. Right? Now let's calculate. So the first bit 0 and 0 exclusive or 1, the result is 1. 1 exclusive or 0, 1, because both are different. 0 exclusive or 1 is also 1. 1 exclusive or 0 is also 1. So all the bits are different here. So the result is going to be 15 again. Okay, now let's check the result. Run this and see exclusive or XOR is also going to be written as 15. I hope till this everybody is clear. Next we have bitwise complement operator. That means let's take some result equals to complement of A. Complement of A. Right? Now let me write C out. C out. What is a complement of A? Complement of A equals to, now let me display the result. Now can anybody tell what is the complement of A is going to be result? So what is the result of complement of 10? What is the result of complement of 10? Anyone please? Are you able to follow my instructions? Are you able to follow? Yeah, please. Yeah, answer is 5. Yeah, Sunil is giving answer is 5. Let's check. Let's check. Hemalata is also saying 5. Chandana is also saying 5. Yeah, sorry. So the result is not 5. Result is not 5. I'll tell you why it is not 5. I'll tell you why it is not 5. Right? So let me switch to my tab. Yeah, listen this very carefully. How the complement operation is going to be performed. And I hope everybody knows what are the values that we store in our computer's memory is stored with a fixed number of bits. Actually, let's say if I take my a value as 10, the binary form of 10 is, of course, it is 1010. But in our computer's memory, it does not store as simply 1010, but it is stored with some specific number of bits format. For example, let's say if it is 64 bits format, if it is 64 bits format, there will be all zeros. That means 64 zeros followed by 1010. We'll be having 60 zeros followed by 1010. For example, if it is 32-bit representation using, if it is using 32-bit representation, then the 10 is stored as 28 zeros followed by 1010. So the complement operation not only works on the first 4 bits, it also applied for rest of all the bits, rest of all the bits, right? Now let's see how the complement is going to be work by picking 8-bit representation. Let's take 8-bit representation, right? So how do I represent 10 in the 8-bit representation? 4 zeros, 1010. This is 8-bit representation. Let me change the color. So in the 8-bit representation, 10 is represented as 4 zeros, 1010 is a 10's 8-bit representation. Now on this, it is going to apply negation. So if I apply negation, this bit will become 1, this bit will become 0, 1, 0, 1, 1, 1, 1. So these all the bits are flipped. That is what complement, or that is what a negation or inverse. Fine. So now you can see, is this is resulting with the value 5? No, it's not 5, because it is not only working on only 4 bits, but it is working on each and every bit in that entire representation. And when it is using, like, let's say if I use 64-bit, you see how many ones we are going to get. We are going to get all these are ones, 60 ones, then it is going to be 01010. right? So all these ones are leading to really a larger value. And in 32-bit also, this is going to become 1, 1, 1, 1, and all ones. Then 0, 1, 0, 1. And this is also going to become really a larger value. It is also going to become a really a larger value, right? And what does our compiler will do is, instead of storing the result of your complement, instead of storing the result of your complement, it stores in the form of 2's complement of your result. Results 2's complement. 2's complement it is going to store, right? And here one more thing we need to remember is about this bit. Usually this bit is called as, this bit is called as MSB, most significant bit, and this is called as LSB, least significant bit. And always the most significant bit will stores the sign, whether it is positive or negative. That means if this MSB bit is 0, which indicates a positive value. If this bit is 1, if this bit is 1, then it indicates negative. Then it indicates negative. Right? So now you see, whenever we apply, negation, on positive value, obviously that value is going to be converted into 1. That means this 0 indicates positive value, and that is complemented to 1, so my result is going to become negative. That means a complement of all positive values is going to give negative result, and complement of all negative value is going to give positive result, is going to give positive result. Getting my point? Yes. So now this bit is converted to 1, so my result is negative. And instead of storing all these as it is, what our compiler will do is, it will convert them into 2's complement. 2's complement. It stores the 2's complement of the result, excluding the MSB bit. Excluding the MSB bit. Right? So now let us consider. So these are my bits. These are my bits. Now for this, you calculate the 2's complement. So what is 2's complement? What is 2's complement? 1's complement plus 1. 1's complement is just inverse of it. So this will become 0. This will become 1. This will become 0. This will become 1. This will become 0, 0, 0. And this is 1's complement. And on this, we need to add plus 1. Adding plus 1. So 1 is represented as 0, 0, 0, 0, 0, 0, 1. And we add this value. Adding. This is adding. That means we are doing plus. Now what happens? 0 plus 1 is 1. 1 plus 0 is 1. 0 plus 0, 0. 1 plus 0, 1. Then 0, 0, 0. And this is going to result with a value 11. A decimal value 11. And the sign bit, the MSB bit, is as it is. So it is 1, so that it is going to become minus 11. The result is going to be minus 11. Right now you check. So we have taken a value as, we have taken a value as 10. So the result is going to be minus 11. Okay, let's check this. And how did I get that minus 11? How did I get that minus 11? Is that exact process without what we discussed so far. It will perform 1's complement and the result is stored by using 2's complement in order to avoid changing more number of bits from 0 to 1. Okay, so let me check the result here. Run this and see the complement of A is minus 11. Is minus 11. Okay, so no need to worry about all these calculation part, all this calculation part. So actually this is how it will perform the complement operation, right? Understood everyone? Understood everyone? How does the complement operator works? How does complement works? Understood? Yeah. She was saying yes, sir. Thank you. Yeah, Sushma is also saying yes, sir. Yeah. Thank you. Thank you. Fine. Right? So, but there is a shortcut. There is a shortcut for any number. For any number, the result of complement is, for example, if I take a value n, the complement of n is equals to n plus 1 in the decimal form, n plus 1 in the decimal form, and changing sign bit. If it is positive, change it to negative. If it is negative, change it to positive. Okay, so that is a trick or a shortcut. For example, you see, if I want to do, for example, my a value is 99. If a value is 99, then what is a complement of 99? Here I will write, yeah, yeah, complement of a, complement of a equals to, so that means complement of 99. Now what is the result I will get? Yeah, it is going to be minus 100. The shortcut is add 1 to it and change the sign. Right, let's check. Yes, now you can see it is minus 100. Now can you guess what is the result for minus 98? So 99. What is the result of minus 99? Complement of minus 99. Complement of minus 99. Ah, yes, very nice, very nice. So what is the shortcut? So minus 99 plus 1, minus 99 plus 1 is going to result with minus 98. Minus 98. And then I need to change the sign. If it is negative value, change the sign to positive. So it is going to become 98. A positive value 98. Save and let's see the result. The complement of minus 99 is 98. Got it? This is how the complement operator works. Clear everyone? Is everybody is clear with this? Yeah, please do respond quickly. Yeah, Lakshmi says Yes, sir. Thank you. Sushma is also saying yes. Thank you. Okay, fine. So this is how the bitwise complement operator will work. Okay. And what about shifting operators? What about shifting over? There are other two operators in the bitwise operators. So if I take a left shift by 1, right? Let us come back to this a value as a 10. Yeah. Now what is 10 left shift by 1? What does it will do? 10 left shift by 1. So 10 left shift by 1 is something like, what is 10? 1, 2, 3, 4, 1, 0, 1, 0 in the 8-bit representation. Now each and every bit is shifted towards the left by 1 position. That means this will shift by 1 position to the left, this will shift by 1 position to the left, this will shift by 1 position to the left, this will shift 1 position to the left, 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 and this will be going ignored. Like that means this is going out of that sequence. Okay, so in this case, what happens? The empty position, that means this is shifted to the next position, next to left position, right? So 0, this is going to become 0, 1, 0, 1, then zeros, 3 zeros, and this empty position is filled with 0. This empty position is filled with 0. Now can you guess what is the decimal value of this 10100? Is it 20? Yes, it is 20. It is 20. Okay, so the result of this operation, that means 10 left shift by 1 is going to give 10 left shift by 1. I will write a left shift by 1 equals to my result. Yeah, end line. Yeah. Save and check the result. The result is going to be 20. You check the result here. It is 20. And similarly, right shift. What about the right shift? So what does the right shift will do? What does the right shift will do? It will shift each and every bit towards the right by 1 position. That means 10 is 1, 2, 3, 4, 5, 6, 7, 8-bit representation. Now each bit from left will shift towards the right by 1 position. That means this bit is going to shift by 1 position to the right. This will shift, 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 and this will go out of this sequence, right? So my result is going to be what? 4 zeros, 1, 2, 3, 4, then 1, 0, 1, and this bit is going to be empty, and this blank one is filled with 0. Blank one is filled with 0. Now this is going to result with 5. 101 is 5. Okay, now you check the right shift. Check the right shift operation is going to be result as 5, right? So this is how the bitwise operators are working. Okay, so but this is not enough for coding rounds. So just we know how does AND operation is working, how does a bitwise OR is working, and how bitwise exclusive OR is working, how complement operator is working, how left shift is working, and how right shift is working. So we know the working of all the bitwise operators, but this is not enough. You have to use these in the coding rounds, right? So before going for solving some problems, before going for solving some problems, let me give some insights of a binary system, a binary representation. Okay, so let me connect my tab. Now you check. There are few uh, properties which binary system follows is. Now let me take all the numbers from 1 to 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And let's write them in the binary format by using 4 bits representation. Okay, so this is going to be 1, 2, 3, 1. And then how the 2 is going to be written? 0, 0, 1, 0. And how the 3 is going to be written? 0, 0, 1, 1. And how the 4 is going to be written? 0, 1, 0, 0. And how 5 is going to be written? How the 5 is going to be written? 0, 1, 0, 1. And how the 6 is going to be written? 0, 1, 1, 0. And 7, 0, 1, 1. And 8, 1, 0, 0. And 9, 1, 0, 0, 1. And 10, 1, 0, 1, 0. So these are all the binary representation of all the numbers from 1 to 10. Now you observe the one of the property here. Check all even numbers. Check all even numbers. And they all are ending with 0. All the even numbers are ending with zeros. And you also check all the odd numbers are ending with ones. Okay, so the first property here is all even numbers LSB is 0, and all odd numbers LSB is 1. This is first property. And second property I want to tell you is check the power of 2's. So what are the power of 2's we have? 2 to the power 1, then 2 power 2, then 2 power 3, right? We have 3 power of 2's here. And can you guess, there is a pattern following in this. Now you check. First power of 2, there is only one set bit. In this also there is only one set bit. In this also only one set bit. That means if I take the power of 2's, 2, 4, 8, 16, 32, 64, 128, 512, 1024, these are all the power of 2's, right? Now you see, this is 10, this is 100, this is 1000, this is 140, right? And this is 150, and this is 160, this is 170, and this is 180. 1, 2, 3, 4, 5, 6, 7, 8 zeros. And this is 190. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. Now see, in all this power of 2's, that means this is 2 power 1, 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, 2 power 8, 2 power 9. Now for all the 2 powers, power of 2's, if you observe this, there is only one set bit. Remaining all are zeros. Remaining all are 0. That means set bit is 1. Unset bit is 0. So that means for all the power of 2's, there will be only one set bit. Remaining all are zeros. So this is one more property that we can observe in binary format. Okay, so the third point is the power of 2's contains only one set bit. Okay, and did you observe what happened when I use 10 left shift by 1? What was the result? It was 20. Right? And when I performed 10 right shift by 1, the result was 5. That means here, just easy to make this calculation. What happens is, actually this is equivalent to 10 into, left shift always will perform multiplication with 2 power number of bits. So this is going to give 20. For example, let's say if I'm doing 10 left shift by 2, so this is going to be calculated as 10 into 2 power 2, so which is going to become 40. If I perform, for example, let's say 18 left shift by 2, right, or left shift by 1, let's say left shift by 1, so this is going to perform 18 into 2 power 1, that is going to be result with 36. That means left shift always performs multiplication with 2 power number of bits shifted, right? And similarly, right shift, if I take right shift, let's say some 5 let's say 50 right shift by 1, 50 right shift by 1, then it will perform 50 division with 2 power 1, 50 division with 2 power 1, which is going to result with 25. For example, if I perform 10 right shift by 2, then it is going to calculate 10 divided by 2 power 2, which is going to give 10 by 4. So 10 by 4 is actually 2.5, but it will ignore this part and the result is going to be 2. That means right shift performs division with 2 power number of bits shifted. number of bits shifted. Okay, so these are the few properties. These are the few properties, right? You can also test them. You can also test them. For example, if I write C out 50, yeah, let me write it in a brackets. 50 right shift by 1 is going to be result as, see, 50 right shift by 1 is giving 25, and by 2, can you guess what is the output I'll get? 50 right shift by 2, 50 right shift by 2, that means 50 divided by 4, 50 divided by 4, that means this is going to perform 50 divided by 2 power 2, so this is going to become 4, so this is going to result with 12.5, but the answer is 12. Save and run this and check the result. Yes, you can see my answer is 12. My answer is 12. Got it? So right shift always will perform division with 2 power number of bits, right? And left shift always will perform multiplication. Okay, so these are the few properties we should know in order to start using these bitwise operators in the problem solving. Right? And now how we can use these bitwise operators in the problem solving. And there are two types of problem statements which are asked based on the bit manipulations, which is working with the a specific positioned bits, or working with the bits of a number, and second thing is making some decisions based on the bits or based on the properties of a binary system. Like for example, check whether a number is positive or negative, or else let's say you have given, let's see, let me take one simple problem statement. Given two integers, a and b, and check whether a and b are of same sign or opposite sign, How do we test this? How do we solve this? Now see, here let us consider a value is, I've given something like 5, and b value I've given something like 7. Now both are positive, yes, so that means both are belongs to same sign, but how do I identify that? Now let's take 8-bit representation, 8 bits representation for a and b. So a is represented as 1 2 3 4 5 1 0 1. This is 5 representation, which is a value. Then similarly b value, how does the b value is represented in the binary format? 7 1 2 3 4 5 triple 1. This is 7, right? Now you observe what does this bit will do. MSB is always representing the sign bit, Now you observe in sign bit, let's apply exclusive OR here. Now whenever I apply exclusive OR, what is exclusive OR will do? If both the bits are same, the result is 0. If both the bits are different, then the result is 1. So if both are belongs to positive, this is going to give 1. That means my MSB bit of the result, that means A exclusive or B, if the result is MSB bit is 1, and whatever the value that I will get here, you forget about that value. It is something value, some value we will get, right? But is it a negative value or not? Because of this MSB bit, that result is going to become negative. That means it is true for both negative values also. For example, let's say if I take let us take A as -5 and B as -15. Then how do we represent A equals to, how do I represent -5? 1, 4 zeros, 1 0 1. This is -5 in the binary representation of 8 bits. And how do I represent B? So B is represented as it is negative, MSB bit is 1, and then 1 2 3 double 1 double 1. Now you apply A exclusive or B. Then as both the bits are same, the exclusive OR is going to give 0 as a result. Sorry, previously I was telling like it is 0, right? Sorry. So if both the bits are same, the result is 0. So whatever we get here, we get some value. Let's take some value we will get, but it is a positive, because MSB bit, if MSB is 0, then it is positive. If MSB is 1, then it is negative. Now tell me, if both the bits are same, that means both are belongs to either positive or either negative, then the result is going to be 0. That means the result of A exclusive or B is positive. Okay, and when both are different, for example, let's say it is +15, then what happens? This bit is going to be 0. Now 0 exclusive or 1 is going to be 1. So 1 always will indicate negative value. That means now if I want to solve this problem statement, it is very simple. Just we apply. Let me remove all these. Let me share these in your Telegram channel. Yeah. TCS. Yeah, just I shared this code. Now you check. Let me remove this now. Till this. Yes. Now let us take A and B. Let us read them from the user. A and B. So now both we are reading. Now just I need to do this thing. What I need to do? Just I need to calculate. I need to identify A exclusive or B value. A exclusive or B value. Let us store that in a temporary. Now, if the result of this, if my temp is equals or is a negative value, or it is a positive value, how do I say that it is a positive value? If it is greater than or equals to 0. if the temp, that result of this A exclusive or B is 0 or more, all are positive values, then I say that both belongs to same sign. Both belongs to same sign. Else I'll say that both belongs to opposite side. Opposite side. Got it? Clear, everyone? Now let's check. So run this. Let us give first time. Both are 12 and 45. Both are positive, so same sign. Both are belongs to same sign. Let's run 34 minus 90. Now both are belongs to opposite sign. Yes, opposite sign. Let's run. Now this time let us give both are negative values. Minus 9, minus 23. So both are of same sign. So answer is same sign. If my first value is negative and second value is positive, then opposite sign. Got it? So here we should know how to use this exclusive OR in order to solve this problem. So this is how we use. For example, now tell me, I'll give another example and then we will pick a few problems asked in the TCS NQT, right? And then we solve based on the bit manipulations. Okay, now let's do one more problem statement here. Now let me share this solution. Yeah, this is a problem statement. Yeah, let me share this solution in the Telegram channel. This is our problem statement. Yeah, done. I shared this. Yeah, now I will give another given an integer n, check whether it is even or odd, without using arithmetic operators. Without using arithmetic operators. Okay, so how do I do this? Can we apply that even or odd property in that? That means, what is the property for even numbers? Are you with me? Are you following the session? Yeah, Shiva, you asked a question. Sorry, I didn't see. But did you get the answer for that? What happens when we use left shift? Ganesh, did you get the solution for that? Yeah, Shiva, it's right. The last bit is 0 for all the even numbers. Yes. Yeah, very nice. Sunil. Yeah, thank you, Ganesh. So what we need to do is check here. We need to do, like for example, if I given n value as something like, let us say I've given 9. Then what is a binary representation of 9? 1, 2, 3, 4. Just always I'm using 8-bit representation, right? And it is going to be 1001 is a 9's binary representation. Now, if I want to tell this even, this bit should be 0 for even, and this bit is 1 for odd. Now, at this moment, so the last bit, LSB bit of 9 is 1, which is saying that it is odd number. It is saying that it is odd number. Okay, but how do I identify that whether this bit is 1 or 0? Whether this bit is 1 or 0. So for that, for almost all bit manipulation related problems, we use an approach called masking approach. So what is that approach? Says that you perform, let's find, the approach says that the step 1 is, just let me write that approach here. First step is find suitable mask. I'll tell you how do I find that mask. And then apply suitable bitwise operation between given number and mask, right? And third step is use the result for making the decisions. Use the result for making decisions. Or sometimes this operation itself will produce the result. Right? And the same approach we used in the previous problem solving. That means what I did here is, let's say first number and second number, on that I applied. That means here we are not using a separate mask. But instead of that, what I'm doing is, we are directly starting with the second step. We are applying a suitable bitwise operation between A and B, and that result, we stored in the temp, and we are using the temp to make the decision whether it is same sign or opposite sign. Okay, now at this moment, if I want to find whether given number is even or odd, then we need to work on LSB. Okay, if LSB is 0, then it is even. If LSB bit is 1, then it is odd. But how do I identify whether LSB bit is 0 or 1? Please note down these points, or I'll just take a screenshot of this while I'm writing. Okay, yeah, now tell me, how do I identify? For example, let's say I've given n value as 9. So that is represented as 1, 2, 3, 4, 1, 0, 0, 1. So what I will do is, here, let us see, I will make all zeros except my LSB bit as 1. Right? So actually this is 9. This is actually 1. This is actually a binary 1 representation. And on this, let us apply AND operation. Now you can see what is the nature of AND operation. 0 AND with something is always going to be 0. 0 AND with something is always 0. That means now you can observe these are all zeros. These zeros with and with something is always zero. That means I will get all our zeros here. 1, 2, 3, 4, 5, 6, 7 zeros. And only this bit is going to be 1 if only this bit is going to be 1 if my LSB bit is 1. Otherwise, this is 0 if this bit is also 0. That means if my result is 0, if my result of 9 and with 1, if the result is 0, then my LSB bit in the 9 is also 0. If LSB bit is 0, then we say that if it is 0, then we say that it is even number. Excuse me. Right? For example, if I get now for this, for 9, my LSB bit is 1, and 1 and with 1 we will get 1. That means if this result is not equals to, or exactly if it is equals to 1, if it is equals to 1, then we say that it is odd number. That's it. Now tell me here, what is my mask? This is my mask. 1 is my mask and this is my n. So I need to perform n and with mask and use this result for making the decision. Okay, so let's put that in a coding. Now let me start from the scratch. Let me take n and let us read the value from the user. And then what is my mask? My mask is 1 here. My mask is 1. And then you perform if n and with my mask, if the result is 1, then I need to print it is it is odd. Else I need to print see out it is even. Okay, that's all. We solve the problem. Now you can see if I give n value as 34 and answer is even. If n value is 57, answer is odd. If n value is 99, answer is odd. If n value is something like this is even. Right? So the approach here is first we need to identify mask and then perform given number some operation, bitwise operation with the mask and use this for getting the result. Sometimes this itself will give the result, or we use this result for making the decisions. So this is a general approach we use for solving the bitwise bit manipulation related problems. Okay, so now let's pick one more problem statement will do. Now let's share this code in your channel. Yeah, we'll do one more problem. Given two integers n and k. Check whether kth bit of n is set bit or unset bit. whether the kth bit of n is set bit or unset bit. So how do I do that? How do I do that? Yeah, now you can see just I'm reading these two values. Now I want to check whether my kth bit of n is set bit or unset bit. How do I identify that? How do I identify that? For example, let's take an example. Let us take an example. N is some 10 and k is some 3. K is some 3. Now let us take a 10 binary representation. 1, 2, 3, 4, 1, 0, 1, 0. Now here the position of bits in binary representation is always taken from LSB towards MSB. The positions are always taken from least significant bit towards the most significant bit. Okay, and the positions always will start from 0th position, position 1, position 2, position 3, 4, 5, 6, 7. Right? Now here my k value 3 means now we are focusing on this bit. We are focusing on this bit. Okay, so for this that means I need to check whether this bit is a set bit, that means is it 1, or unset bit, that means is it 0, that I need to check. Okay, so for that what we are going to do is I will pick a mask such that the bit where you want to perform testing will be 1 and remaining all are zeros. Right? This is my mask. Now you apply AND operation on this. Now you can see what AND operation will do. These all zeros will come as it is. These zeros will come as it is. But this bit is going to be 1 if my kth bit is 1. And this bit is 0 if my kth bit is 0. 0 and 1 will become 0. 1 and 1 will become 1. Right? That means whenever it is 0, let's assume that if it is 0, that means my entire result is becoming 0 or not? It is becoming 0. That means if I do n and with my mask, if the result is equals to 0, then my kth bit is unset bit. Kth bit is unset bit. Otherwise, that means if this is a case, it is unset. Else, it is a set bit. That's it. But how do I identify this mask? How to get this mask? It is very simple. Getting mask is very simple. Now let's see. What I will do is my mask is, how do I frame the mask? I will take number 1. Sorry. This is 1. I'll take my mask as 1. I want to shift this by k positions to the left. That means left shift by k positions. So if I left shift by k positions, what happens? This will become 1 and remaining all are become 0. So this is going to become my mask. That's it. That means We need to identify the suitable mask, and always the mask is framed in a such a way that the bit where you want to perform some testing will be 1 and remaining all are zeros, or sometimes it may be reverse where the testing bit will be 0 and remaining all are ones. Sometimes it may be in this fashion also. So according to our requirement, we need to choose the mask. Okay, so now let's code this. Let's code this. Now what should I do? Get a mask. What is my mask? 1 left shift by k positions, right? And then if my operation, what is operation? N and with mask. If this is resulting with 0, then what is my kth bit? What is my kth bit? Is, sorry, unset bit. Unset bit. Right? Else my kth bit is a set bit. That means other than 0, it is going to be a set bit. That's it. Now you can check. Run this. I'll give the same input. 10 and 3. 10 and 3. So check what is 10. 10 is 1, 2, 3, 4, 1, 0, 1, 0. So my k value is 3. 3 means fourth bit. This bit. So is this bit is set bit or unset bit? It is a set bit. So I need to get the answer as set bit. Answer as set bit. Now you can see it is set bit. Right? And let us give the same input. N value is 10, but k value is 2. So what is k value 2 means? So 10 is 1, 2, 3, 4, 1, 0, 1, 0. And 2 means this bit. K value 2 means this bit. And this bit is unset bit. So my answer should be unset bit here. Yes, it is unset bit. Okay, so this is how we need to use the mask concept. So we need to identify the suitable mask, then apply any operation between the given number and mask, and use the result for making the decisions. Got it? So this is how we need to solve problems based on bit manipulations. Clear, everyone? Yes? Are you with me? Are you able to follow the session? Lakshmi, Ganesh, Sunil, Chandana. Are you able to follow my session? Yes. Thank you, Lakshmi. Yeah, thank you. Thank you all. Fine. So now let's pick one of the problem statement asked in TCS NQT. Right? The problem statement says that given two integers a and b. Given two integers a and b. Then find the number of bits. Find the number of bits to be flipped. To be flipped to be flipped to convert A to B or B to A. So this is one of the problem statement. That means you have given two integers and we need to identify how many bits I need to flip in the A to make it as B, or vice versa. How many bits I need to flip in order to convert B into A. Let's understand with an example. Let's understand with an example. For example, let's say my A value is 10 and my B value is 5, right? And 10 representation is 1010 and 5 representation is 0101. Now tell me how many bits I want to change. Sorry, how many bits I want to change or I want to flip in A in order to convert that as a B. So I need to change this bit to 0, I need to change this bit to 1, I need to change this bit to 0, and I need to change this bit to 1. So if I want to convert A to B, I need to change 4 bits. I need to flip 4 bits. Same thing, same thing. If I want to convert B to A, if I want to convert B to A, so this bit should be converted to 1. This bit should be converted to 0. This bit should be converted to 1. This bit should be converted to 0. So again, this also needs 4 bits to be flipped. So if my input is 10 and 5, the answer should be 4. The answer should be 4. And same, for example, let us take A is 10 but B is 7. B is 7. So what is B now? B binary format 111, right? Now tell me how many bits I need to change, how many bits I need to flip, how many bits I need to flip to convert from A to B or B to A. See, do I need flipping this bit? Yes. Do I need flipping this bit? Yes. But this bit I don't need to flip because both are same. And do I need to flip this bit? Yes, I need to flip this bit, right? So I need to flip 3 bits. I need to flip 3 bits in order to convert 10 to 7 or 7 to 10. So this is the problem statement. This is the problem statement. Now tell me, how do I solve that? Tell me, how do I solve this? Yes, just I'm taking two input values A and B from the user. How do I get this? Anyone please? Any idea about this? Did you get the question? Is everybody clear with the question? Please do respond. Are you clear with the question? Are you clear with the question? Okay. Lakshmi says, clear, sir. Okay, fine. Thank you. And is my screen is blocking that output here? Okay, I'll change that format. Yes, please. So if the question is clear, just think about the solution now. Think about the solution. Anyone? Any idea, please? So you have given two numbers A and B, and then check how many bits need to be flipped. How many bits need to be flipped in order to convert A to B or B to A. Okay. So the very simple solution is, let's first identify how many bits which are common in both the representation. For example, let's say A is some 10 and B is some 5, or else let's take B is some 1010. Of course, we'll be having 0000 also. Fine. 8-bit representation. Now, what is 15? 1, 2, 3, 4. 1, 2, 3, 4. 1111. Okay. Now, what I will do is, so this is A, this is B, and C. What I will do is, I will perform A exclusive or B, and see the logic here. When I apply A exclusive or B, what happens? What the exclusive OR will do? If both the bits are same, the result is 0. If both the bits are different, the result is 1. Here the logic is, if both are same bits, they do not needs to be flipped. They do not needs to be flipped. We can leave them as it is. But if the bits are different, then they need to be flipped in order to convert from A to B or B to A. Okay, so that means now we are trying to find out. Now these first bits, LSB, starting from LSB, is this bit both are same or both are different? Both are different, so I'll get 1. This is same, 0. Different, 1. Same, 0. Same, 0. Same, 0. Same, 0. Same, 0. Now you see in the result, only wherever we have the ones, only that bits we need to flip in order to convert from A to B or B to A. Only that bits need to be flipped. And wherever we have zeros in the result, those bits need not to be flipped. Now you can guess how many bits I will need to flip in order to convert from A to B or B to A. 2. So that means you find exclusive OR. Of A and B first. Right? Now let me take some temporary and find A exclusive or B. And with this, what we are getting? My temp will contain ones where we need the flipping and 0 where we do not need the flipping. And then count how many ones are there in the temp. So this is finding 0 for no flip and 1 for flip. That means this result, the temp will contain 0 for no flipping operation and 1 for flipping operation. Right? So wherever I need a flip, I need to just count how many ones are there in the temp. So how do I count? For counting, simply we use, as long as my temp is not equals to 0, then just let me create a variable called counter. Initially set it to 0, and then you check if my temp if my temp and with 1 and with 1 equals to temp right shift by 1 position. Now this will count the total number of ones in the temp, right? And my answer is going to be counter. My answer is going to be counter, right? So this code is for counting number of set bits in temp, number of set bits in temp, right? And that is what the number of bits we need to flip. That is what the number of bits we need to flip. Okay, so now let's check the answer. Let us give run this. Let us give 10 and 5. If I give 10 and 5, all the 4 bits need to be flipped. Yes, I need to flip 4 bits. Now let's check 10 and 15. If 10 and 15, only 2 bits I need to flip. So 10 and 15 goes like this. So 10 is 0 0 0 0 1 0 1 0 and 15 is 0 0 0 0 1 1 1 1. Now you see only this bit and this bit we need to flip. Remaining all are same. Only 1 and 2. So we need to flip only 2 bits. You have to convert from 10 to 15 or 15 to 10. Okay, so my answer should be 2 because I need 2 bits need to be flipped. Yes, you see, I'm getting answer as 2. Okay, now tell me if I give 15 and 0, 15 and 0, what should be the answer? 15 and 0. So 15 is double one, sorry, double one, and 0 is 0 0 0 0. Now you can see if I want to convert to this from triple one, double one to double zero, I need to flip each and every bit, and this also I need to flip each and every bit. So I need 4 bits need to be flipped. I need to flip 4 bits. Right now you can see answer is 4. Clear? And 7 and 0, 3 bits. Let's say 10 and 10, both are same. So 0 number of bits need to be flipped. Yes, answer is 0. Got it? So this is how we can solve this problem. Clear, everyone? Let me share this solution here. So are you clear with the solution now? Are you clear with the solution? Please do respond. Are you clear with the solution? Are you clear with the solution? Yes, Ganesh says that yes. Thank you. Please be active. Please be active. Yeah, Sunil is also saying clear, sir. Thank you. Yeah. So still those who are having a little confusion, please go through that code which I shared in the Telegram channel. Please go through that code once. Okay. And still if you have anything, please post that query in the Telegram channel. So I'll try to make it clarified. Okay. So take this input content, take this content in order to solve the next problem. So directly I'll post that in your Telegram channel. So which was asked in, yeah, last year TCS NQT. Yeah. So this was the question asked last year. Let me pose this question. Let me pose this question in your Telegram channel. Where is the Telegram channel? Yeah. Take this as assignment. Yeah. Take this as assignment. Today assignment. Yeah. I request everyone, please go through this problem statement. Now, what does the problem statement says? You see, the problem statement says that Joseph is learning a digital logic subject, which will be for his next semester. He usually tries to solve a unit assignment problem before the lecture. Today, he got one tricky question. The problem statement is a positive integer has been given as an input and convert decimal value to binary representation and toggle all the bits of it after the most significant bit and print the positive integer value after toggling all the bits. Right? I'll tell you this with an example. If input is 10, if input is 10, if the input is 10, right? So how do I represent 10? The 10 is represented as 1010. Now if I toggle each and every bit, that means toggling means this will be converted to 1, this is converted to 0, this is converted to 1, and this is converted to 0. Then this result is going to give as a 5. So answer is 5 now. But what is this? What is this? Toggle all the bits of it after the most significant bit. The meaning of this is do not disturb the MSB, because whenever we toggle a positive number, then it will become a negative. The toggling will become negative, right? But if you observe the problem statement, print the positive integer value after toggling all the bits. That means we should not disturb the MSB bit. Excluding the MSB bit, and on remaining bits you need to perform the flipping. And also this, observe here, the problem statement says a little tricky here. If you observe here, the answer for this is 5. But how do I get 5? Because if I take 10 in the 8-bit representation, 1 2 3 4 1 0 1 0, and we exclude this. But if I flip each and every bit, if I toggle each and every bit of 10, so this will become 1, this will become 1, this will become 1, this will become 0, this will become 1, this will become 0, this will become 1. Right? But this does not give the result 5. This does not give the result 5. But the result for 10 is 5. Result for 10 is 5. That means this unnecessary bits We should not disturb, right? You need to flip only the bits, which are originally representing your number, but not all the rest of the bits, right? For example, that means if the input is 7, so only we need to flip last 3 bits, only. But remaining all these zeros, we should not disturb. This. They should be as it is. Only these need to be flipped. Okay. So this is what the problem statement says. That means for this the output is 5. Okay. Now think about the solution. How we can solve this problem. Okay. Just think about this. This question was asked last year TCS NQT. I hope you are clear with the question. Are you clear with the question? Yes, please. Are you clear with the question? Are you clear with the question? Yes. Okay. Yeah. Please try to solve that problem. And if you are facing any issues, post that in the Telegram channel. I'll do respond to that. So that's all for today. So thank you all. We'll meet you in the next session with arrays and strings concept. And please be prepared for arrays and strings concept by learning basic concepts of arrays and strings concept in C++. Thank you all.